All right, today we're going to review for your conceptual unit 1 test, which is over systems of equations. So number 1 says, fill in the blank in the sentence below so that the resulting statement is true. A solution to a system of linear equations in two variables is an ordered pair that satisfies an equation? No. Well, yes, but does not satisfy either? No, that wouldn't be a solution. It satisfies both. Okay, so this is half true, but it's got to satisfy both equations in the system to be a solution. Okay, so it says when solving this system by the substitution method, x equals 1/2 is obtained. Find the solution set. So they're telling me that x is 1/2. I could solve this whole thing myself, take this y, substitute it in for this y, and solve it. But they already told me that x is 1/2. So if I already know that x is 1/2, doesn't matter what side you put it on either side and plug it into the other one. I plugged it into this one because it looks simpler. So I have y equals 2 times 1/2 minus 4. Half of 2 is 1. 1 minus 4 is -3. So my solution is 1/2 -3. Okay. All right, fill in the blank in the sentence below so that the resulting statement is true. A system of two linear equations that has no solution is called inconsistent. If you attempt to solve such a system by graphing, you will obtain two lines that are parallel. No solution means they never cross. So if they never cross, they are parallel. All right, consider this following system. It says when solving the system by the substitution method, you get 12 equals 12 is obtained. What is the solution set? What they're telling you is that they solved all of this and they got 12 equals 12. So whatever they did, all the variables canceled out. And when that happens, if what's left is true, then you have infinitely many solutions left. If you end up with something that's false, like 0 equals 2 or whatever, then you get no solution. When you get infinitely many, it means you have the exact same line. One is just a multiple of the other. If you look, if I take this line, or this equation, and I multiply everything by 3, I get 3x equals 9y plus 12. If I put it in this form and move this over, I get 3x minus 9y equals 12. These two lines are the exact same line. They just made it look different. If it's the exact same line, it's graphed right on top of each other, which means they share all points for solutions, and that means the system is dependent. And it says if the system is solved by graphing, the two lines are identical or they coincide. In other words, they will be right on top of each other. Okay. All right, number 5, it says a company's blank function is the money generated by selling. The money generated by selling is a revenue. Okay, the difference between this function and the company's cost function, so they're saying if you took the revenue and subtracted the cost, what would you get? Well, that's called the profit. Okay, so this one says solve by the substitution method. It really doesn't matter. You can solve it any way you want. I am going to do substitution because my second equation already has a letter all alone for me. So when we do substitution, your first step is always to pick a letter and get it alone. Well, Merry Christmas, Happy Birthday to me. They've already got y alone. So I'm good to go ahead and do my second step, which is substitute it into the other equation. So I have x plus what I'm going to plug in, and it tells me that that y that I took out is worth a -3x, so I put that in here. That gives me x minus 3x equals -8. So this would be -2x equals -8. Divide by -2, and x equals 4. Now I can take that and substitute it into the other side, and I get y equals -3 times 4. So y equals -12. So my solution set is x, comma, y. Yeah. All right, number 7, it says solve the given system by the substitution method. Again, I'll do it just to show you substitution again. But remember, in a test type situation, I don't care what method you use. If you prefer elimination, do elimination. I would actually do elimination because everything lines up so pretty. But they want me to do substitution, so I'll do substitution. So your first step is to pick a letter, get it alone. If I pick him, I'm going to get fractions because that's not a 1. That's not a 1, so if I get y alone, I get fractions. That's a 1, so this is my guy. That's who I want to get alone, no fractions. If I picked this guy, that's not 1, so I'm going to get fractions. So this is my star. Alright, so if I get him alone, I'm going to add 3y. That gives me x equals 3y. So now if I come over and I substitute it in, I get 3 times whatever I'm bringing, plus 2y equals 0. And I'm bringing an x that's worth 3y. Distribute 9y plus 2y equals 0. That's 11y equals 0. Divide by 11, and y equals 0. Plug that in over here, and I get x equals 3 times 0, which is 0. So my solution set is 0, 0. Okay. Alright, so they want me to solve this one by substitution also. So I have 7x plus 8y equals negative 24. 4x minus y equals 3. So I'm going to pick a letter to get alone. That'll make fractions, that'll make fractions, that'll make fractions, that won't make fractions. So that's my star. So to get it alone, I'm going to minus 4x. That gives me negative y equals negative 4x plus 3. Divide by negative 1. And I get y equals 4x minus 3. Now that I got a letter alone, I can cross over and plug it in for y. So I'm going to have 7x plus 8 parentheses equals negative 24. And I'm going to plug in 4x minus 3. And I'm going to simplify. That's going to be 7x plus 32x minus 24 equals negative 24. So this is going to give me 39x. And if I add 24 to both sides, I get equals 0. Divide by 39, and I get x equals 0. So if I take that over and substitute it here, I get y equals 4 parentheses minus 3. Plug in what I brought, which is 0. Solve that, I get y equals 0 minus 3. So y equals negative 3. So my solution set is 0, negative 3. Okay. Alright, this one says solve by the addition method, which, we call that the elimination method. Same word, means the same thing. So when you do elimination, you line them up vertically instead of horizontally like we did when we were doing substitution. And you decide which letter you want to eliminate, which I'm going to pick the x's. And so when you pick the x's, I'm picking the x's. So when I pick the x's, sorry, let me go back to a pen here. You multiply the top by the bottom and the bottom by the top. So 5 goes up, 1 comes down. When they come out the same, you need to make them different. If they come out different, you need to make them the same, otherwise your variable won't cancel out. So then you distribute through. That gives me 5x plus 25y equals 35. This gives me negative 5x minus 3y equals positive 9. And now when I add them up, x's cancel. 25y's take away 3y's is 22y. 35 plus 9 is 44. Divide by 22, and I get y equals 2. So now I'm going to take that and substitute it into one of the originals. I'm just going to go to the bottom. So that would be 5x, oops, let me change colors. 5x plus 3 parentheses equals negative 9. I'm plugging in 2, so that gives me 5x plus 6 equals negative 9 minus 6. 5x equals negative 15. Divide by 5. X equals negative 3, so my ordered pair is negative 32. Yeah. Alright, so I solve the system by the method of your choice. I choose substitution because handy dandy, they gave me an equation with the letter all alone. So substitution, I'm lining them up side by side, horizontally. And Merry Christmas, Happy Birthday to me. X is already alone, so I'm going to go over and substitute, which means I'll have negative 3 parentheses plus 6y equals negative 3. This says that an x is worth 2y plus 1, so I change x to 2y plus 1, and I simplify. Distribute the negative 3 is negative 6y minus 3 plus 6y equals negative 3. And what happens is a negative 6y and a positive 6y cancel each other out, and what's left is negative 3 equals negative 3, which is true, which means there are infinitely many solutions. Alright, again, solve by the method of your choice. See how everything, x's line up, y's line up, equal signs line up, constants line up. That is perfect for elimination. So elimination, I line them up vertically. 7x minus 2y equals 8. 4x plus y equals 11. Pick a variable to eliminate. I'm going to pick the y's. They're smaller. So bottom to the top, top to the bottom. They came out different, so I need to make them the same. And I like positives better than negatives, so I'm going positive. So distribute, I get 7x minus 2y equals 8. Distribute the 2 on bottom, I get 8x plus 2y equals 22. And now when I add them, I get 15x. The y's cancel. And over here I get 8 and 22 is 30. So divide by 15, and I get x equals 2. Substitute it back into one of the originals. I'm going to go to the bottom, which gives me 4 parentheses plus y equals 11. And I'm changing my x to 2. So now when I solve that, I get 8 plus y equals 11 minus 8 minus 8, and y equals 3. So my ordered pair is 2, 3. Okay? Alright, it says use the given conditions to write a system of equations and then solve the system and find the numbers. Your first sentence says the sum of two numbers is 7. So one number, I don't know, call it x. Sum means plus. The second number, I don't know it, call it something different because you don't know they're the same. Is your equal sign, 7. Your second sentence says if one number is subtracted from the other, the result is 3. So that would be if you subtract them, you get 3. Well, there's my system, and happy birthday, Merry Christmas to me. I don't have to multiply the top by the bottom or the bottom by the top at all because the y's are ready to cancel. So this becomes 2x equals 10, divide by 2, and x equals 5. Substitute that back into one of the originals, so that would give me parentheses, minus y equals 3. Plug in x, which is 5, which gives me 5 minus y equals 3. Minus 5 minus 5, negative y equals negative 2. Divide by negative 1, and y equals 2. So my solution is 5, 2. Alright. Oh, I forgot to fix this. Hold on just a second. I fixed it. Okay, so it says use the graphs of the linear functions on the right. Write the linear system whose solution set is 6, 2. Express each equation in the system in slope-intercept form. So I'm looking for a solution of 6, 2, which means over 6 up 2. Well, that's this line right here, which is x minus y equals 4. And this black line right here, which is x plus 3y equals 12. There's my system, but they want it in slope-intercept form, which means get y alone. So if I get y alone on this one, minus x, I get negative y equals negative x plus 4. Divide by a negative 1, and I get y equals x minus 4. To get y alone here, I'm going to minus x. That gives me 3y equals, that's negative 1x plus 12. Divide by 3, divide by 3, divide by 3. Y equals negative 1/3 x plus 4. There's my system. Okay. It says the figure shows the graph of the cost and revenue functions of a company that manufactures and sells small radios. Use the formulas below to find R of 200 minus the cost of 200. And guys, what you're finding, and it says describes what it means for the company. When you take revenue minus cost, you're finding the company's profit. Okay? So if you're doing R of 200, that means you're using this function. So the R function says copy everything but change x to 200. Okay, then I'm going to minus, and then I'm going to do C of 200. I'm going to use parentheses because I'm subtracting it, and if there's more than one thing, I'm going to get in trouble. The C function says take 15,000 and add 26 times your x, which I'm going to change to 200. So now if I simplify that, 47 times 200 is 9,400 minus parentheses, that is 15,000 plus 52 minus, plus 5,200. So when I distribute that negative, I get 9,400 minus 15,000 minus 5,200, which gives me a grand total of negative $10,800. So their profit is not very good. They're losing money. Okay, so it says which of these following statements is true? The company's losing money because revenue is greater than the cost? No. There's your revenue. There's your cost. This is way bigger than that, obviously. The company's losing money because the cost is greater than the revenue. Ding, 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 ding. The company is breaking even. No, if it was breaking even, this would come out to be 0. That would mean your profit is 0. The company is making money means that your profit would be positive. And that would only be, this would still be false, because to make a positive profit, your revenue has to be greater than your cost, which is what would happen here. Okay, again, but that would be your profit has to be positive, and it wasn't. All right, so a company that manufactures small canoes has a fixed cost of $18,000, and it costs $100 to produce each canoe. So to get my cost function, that is going to be your fixed cost of $18,000 plus $100 per canoe that you make. So there's my cost function. My revenue function, you're selling it for $200 per canoe. So A wants me to write the cost function, which I just did. B wants me to write the revenue function, which I just did. And C wants me to determine the break-even point, which is where the lines intersect. So they're telling me to solve that system of equations. So my cost function, written with y notation, would be y equals 18,000 plus 100x. My revenue function using y notation would be y equals 200x. I'm going to do substitution because I have two letters alone, actually. I'm going to plug this y in over here. So I'd have parentheses equals 18,000 plus 100x, and I'm plugging in 200x. So if I start solving this, I'm going to subtract 100x, subtract 100x. That gives me 100x equals 18,000. Divide by 100, and x equals 180. Plug it in over here, I get y equals 200 times my x value that I just found was 180. Multiply, and I get y equals 36,000. So what that means is, there's the break-even point, and that means is, if they make 180 canoes and sell 180 canoes, the cost will be 36,000. The revenue will be 36,000, which means the profit is 0, which means the money coming in equals the money going out. Okay? Alright, it says use a system of linear equations to solve the following problem. A new restaurant is to contain 2 seat tables and 4 seat tables. Fire codes limit the restaurant's maximum occupancy to 60 customers. So, and it has hired enough servers to handle 19 tables of customers. So whatever this place is, there's 2 seat tables and there's 4 seat tables. Okay? Well, they're telling me 2 things. The number of seats can't go past 60 because the restaurant can't handle more than 60 customers. Well, if I say let x equal the number of 2 seat tables, let's call them 2-seaters, and let's let y equal the number of 4-seaters, the first constraint that they give me is that I can't go over 60 customers. So the number of seats has to be 60 or less. Well, for every one of these x tables, there's 2 seats. So the number of customers that can sit at each one of those is 2 per x table. Because we're talking people, so I got to have people touching my variables. Plus, every 4-seater table can handle 4 customers. So 4 times y would be how many people could sit at the y tables, but that can't go over 60. So there's my first equation. My second limit, my second constraint, is that you can only have, there's only enough servers to handle 19 tables total. So how do I know how many x tables and how many y tables to make? Well, that's just number of tables. So the number of these plus the number of these has to equal 19 tables. Okay, so there's my system. Lines up pretty, so I'm going to use elimination, and I'm going to eliminate the x's, so bottom to the top, top to the bottom. They came out the same, so I'm making one negative, doesn't matter which one. That's going to give me 2x plus 4y equals 60. Negative 2x, negative 2y, negative 38. The x's cancel, subtract the y's. 2y equals 22. Divide by 2, and y equals 11. Substitute it back into one of the originals. So I have x plus parentheses equals 19. My y parentheses is 11, so I have x plus 11 equals 19 minus 11. X equals 8. So there should be 8 2-seat tables and 11 4-seat tables. And if you check it, that's a total of 19 tables. And if you have 2 people for this, that's 16 people. 4 people for that, that's 44, which is a total of my 60 customers. Okay? Alright, the next one says use a graphing utility to graph the 2 equations in the system in the same viewing rectangle. Then use the intersection feature to display the solution. You can't use a graphing utility until you get y alone. So I have x plus y equals 4. To get y alone, I'm going to minus x, which gives me y equals negative x plus 4. To do the second one, I have x minus y equals 3. to get y alone. I'm going to minus x, which gives me negative y equals negative x plus 3. Divide by negative 1, divide by negative 1, and I get y equals x minus 3. So then I'm going to go to my graphing calculator, and I'm going to go to y equals, type in negative x plus 4 for y1, and x minus 3 for y2. When you hit graph, you get this picture. Then you go to second calc, and choose intersection, and then it'll say first curve, second curve. Just hit enter, 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 and it will zoom in on the intersection point, which is 3.5, comma 0.5. Okay. Number 18, fill in the blank so that the resulting statement is true. Consider the following system. It says eliminate y from equations 1 and 2. 1 is this. 2 is this. If they want me to eliminate y, guys, then negative 3 would go to the top, positive 1 would come down, but since they came out different, I make them the same. So if I want to eliminate y from equations 1 and 2, I need to multiply equation 1 by 3 and add the equations. Okay, so then it says eliminate y from equations 1 and 3. Well, 1 is x plus y minus z equals negative 3. And equation 3 is 3x plus y minus 3z equals negative 11. If I was going to kill y on this set, bottom to the top, top to the bottom, they came out the same, so I need to make one of them negative. And it's saying multiply equation 1 by something, so they're saying make that one negative 1, and then if I add them, I could finish solving. Alright, this next one wants me to determine whether this ordered triple is a solution to the system. Well, if it's a solution to the system, then when you plug them into all three equations, you get a true statement. So if I take my first equation, x plus y plus z equals 0, and I plug in my x, y, and z, that would be 4 minus 6 plus 2 equals 0. That's negative 2 plus 2 is 0 equals 0. So yes, it works in that one. That doesn't mean it's a solution yet. It has to work in all three. So if I check the second equation, x minus 2y minus z equals 14, and I plug in my variable or my numbers, I have 4 minus 2 times negative 6 minus 2 equals 14. That's going to be 4 plus 12 minus 2. That's 16 minus 2, which is 14, which equals 14. So 2 out of 3, so far so good, but it's got to work in all three. So my third one, 2x minus y minus 2z equals 10. 2 times 4 minus a negative 6 minus 2 times 2 equals 10. That's 8. That's plus 6. That's minus 4 equals 10. That's 14 minus 4, which is 10 equals 10. So it works in all three, which means it is a solution to the system. And then finally, they want us to solve one of these bad boys. And this one actually came out very, very nice. So when you're solving a given system, you pick two, line them up, pick a different two, line them up. I usually always pick 1 and 2 and 1 and 3. Is that standard? No, that's just my habit. So the first time I'm going to line up 1 and 2. X plus y plus 4z equals 10. X plus y plus 5z equals 12. And then I'm going to line up 1 and 3. So x plus y plus 4z equals 10. And x minus 2y minus 8z equals negative 23. I'm going to pick a variable to eliminate. And I picked y's because, especially on this one, they're already the same. I just need to make their signs different. So bottom to the top, top to the bottom. They came out the same. I make my bottom negative. And that's going to give me x plus y plus 4z equals 10. Negative x, negative y, negative 5z equals negative 12. And Merry Christmas, Happy Birthday to me. This doesn't happen often, but two variables canceled out, which gives me negative z equals negative 2 divided by negative 1, and I get z equals 2. That's always a blessing, because usually you get down to two variables in two equations, and same here, and then you have to line them up before you get an answer. So if I solve the other set that I set up, and I have to kill y's, otherwise it's not going to make any sense. You don't want to kill different things, otherwise they won't line up if you need them to. So if I'm doing y's, negative 2 goes up, positive 1 comes down. They came out different, so I need to make them the same. So on top I'd have 2x plus 2y plus 8z equals 20, and on bottom I'd have x minus 2y minus 8z equals negative 23. And Merry Christmas, Happy Birthday to me again, because the y's and the z's cancel, which gives me 3x equals negative 3. Divide by 3, and x equals negative 1. So now that I know two of my variables, I can go plug them into one of my originals. So if I go there, I have x plus y plus 4z equals 10. Plug in my information, I have negative 1 plus y plus 4 times 2 equals 10. That's negative 1 plus y plus 8 equals 10. That's y plus 7 equals 10, minus 7, and y equals 3. So my ordered triple is negative 1, 3, 2. Alright, we are done, so happy studying, and I will see you next time.